Today in Capecchi's Corner, we're going to look at variables and expressions. So looking at the first vocabulary word, the word variable, we know that that means any letter used to represent unspecified numbers or values. We most often use the letter X, but we could use the letter Y or the letter M, any variable at all, any letter. An algebraic expression is our next word, and that consists of sums and or products of numbers and variables. So for example, 7x is an algebraic expression. 4x minus 6, even though there's a subtraction symbol in there, that is still an algebraic expression. I could even have something a little bit more involved, such as 10bc divided by 4de. The biggest misconception about an algebraic expression is that it has an equal sign, but that's not true. An equation has an equal sign. And the next word we're going to talk about is the word term. So if I have something such as the example of 2x plus 4, a term may be any number or variables or product of those. So when looking at 2x plus 4, because 2x has a variable, we call that a variable term. And because the 4 is actually by itself, that's called a constant. So this is our variable term. And the 4 by itself we call a constant. Now the next thing we're going to look at is some powers and some exponents. So when we have something like x to the nth power, that big value on the bottom is called the base. The base is what holds things up. So that is our same thing that happens in math. The n, what powers it's raised to, we call that a power. We also call that an exponent. Okay, in our first example here, we have 5x to the fourth. So we would actually write that as 5 times x to the fourth power. And between the 5 and the x, that's multiplication. So it's actually 5 times. And that fourth power tells us there are 4 of what's inside. There are 4 times x. So I have 4 times x because x is raised to the fourth power. Now, looking at adding and subtracting, multiplying and dividing, there are some math terms that we use all the time. The big one we use for addition is we use the word sum. That's a common one. We can also use things such as more than. That phrase means addition. We can use plus. We can also use increased by. That also means to add. And we can also use added to. And looking at our subtraction phrases, we have subtracted from. We also have less than. The biggest word that we see a lot in word problems is difference. We also see decreased by. And another word is minus. So all of those words stand for subtraction. In working with multiplication, we have the word product. That's another common one that we see a lot. Multiplied by is also a math phrase. That's easy to identify because it has the word multiply in it. Times is one when you learned your times tables, you knew you were multiplying. And another big one is the word of. We also see that a lot in word problems. For division, quotient means you're dividing something. That's an answer to a division problem. We also use the phrase divided by, which again is easy to identify that it goes with division because the word divide is in there. When we're looking at phrases and we have a verbal model, we want to make sure we're doing this correctly algebraically. We just want to break things down into smaller chunks. So we have 10 less than. So that less than phrase is important. We know that means subtraction when we look back at our list. And the word product stands for multiplication. So if I have 10 less than the product of 7 and f, I know I first need to multiply 7 times f because of the fact that it says 10 is less than that. So we're going to start with our 7f. We're going to subtract 10. So that means 7 times f minus 10. In number 2, we have 2/3 of the volume f. Of means multiplication, so 2/3 is a fraction. I know that volume, they tell us, is symbolized with V, so I have 2/3 times V is 2/3 of volume V. Our next problem is a word problem. I didn't write everything out, but I'll read it to you. Mr. Martinez orders 250 keychains, so that's written out, that's our important piece of information, with his athletic team's logo and 500 pencils printed with their web address. Write an algebraic expression that represents the cost of the order. Now remember, an algebraic expression does not have an equal sign. So we're not asking to solve anything, we're just writing an expression. Let K be the cost of each keychain. So that's K, and P is the cost of each pencil. So now I have to kind of think about this a little bit. If I have 250 keychains and they cost K, whatever K is, cents or dollars, then my expression is going to be 250K. 250 is the number I have, and K is the cost of each keychain. Now I'm also ordering pencils, so I need a plus there. We're going to do the same idea. 500 is the number of pencils, and P is the cost of pencils. So my algebraic expression is going to read 250K plus 500P. The next problem talks about Mr. Nehru. He bought 2 tickets that are for adults and 3 student tickets for his family to attend the planetarium show. Write an algebraic expression that represents the total cost for his family to attend the show. Let A be the cost of adult tickets, so there's my A, and let S be the cost of the student tickets. So there's 2 adults going. The value of each ticket is A, so it's going to be 2 times A. Can't forget the kids, so there's the plus. Mr. Nehru is taking 3 students, so he has 3 times S. So my algebraic expression is going to be 2A plus 3S.